Thank you for joining us. You're watching a career success video from Computer Coach. Computer Coach is a Tampa-based computer training center specializing in helping IT and business professionals add on the skills they need to reach their desired career goals. If you are job searching, in transition, or are looking for guidance, please feel free to reach out to us at www.computercoach.com. Now, let's get started.
Okay, hi. Welcome, everyone. Thanks for joining us today on this Friday morning. My name is Danielle Ori. I'm the Director of Career Services here at Computer Coach. We're a tech-based training school in Tampa Bay, Florida, and we have both full-time and part-time courses in a variety of areas, but our core areas are coding, cybersecurity, infrastructure or cloud, data, and then a variety of those tech-adjacent topics like digital marketing and project management. So again, I'm so glad you joined us today. You know, if you decide to explore training with Computer Coach, you're not just joining a community of passionate learners, you are joining a group of people who are really committed to your success, whether you're looking to become an IT professional for the first time, or you're a career changer or looking to break into tech for the first time. So if you have any questions or would like further details, don't hesitate to reach out to me. And so without further ado, I am going to turn it over to Jay, who's going to talk about a really exciting topic today in DevSecOps. Please go ahead and feel free to engage in the chat and use the Q&A feature for specific questions that will be answered either during the presentation, if it makes sense, and certainly at the end, we'll leave time. Hey, Jay, turning it over to you.
Hello, can you hear me?
I can hear you just fine.
All right, hello everyone. So welcome to this webinar. So I just want to maybe start with kind of introducing myself. We don't have that many people, so we do have the QA at the end, but you feel free to stop me. And then, if you have a question or if, you want some clarification or whatever, just stop me in the middle, just raise the hand, and then we can answer it right away. But we do have, the plan was to actually have a presentation for about 40 minutes and then have like 20 minutes for, interactive discussion, questions, and also for you to share your experiences as well if you want to. So my name is Jay. I'm here today to talk about DevSecOps. So I've been in IT industry for more than 30 years, and I have been in many different roles. I was a developer role. I ran a production support team, managed development teams, involved in different projects, including implementing Agile, DevOps, DevSecOps. And my current role is managing asset management, corporate IT, and information security teams. So I think having 30 years and, going through all these different roles gives me a little of, unique view on the topic, and hopefully it's also going to be beneficial to you guys as well. First, I want to kind of take you through kind of my plan, what I wanted to do today. I wanted to start with what is DevSecOps, because again, I'm not sure what your level of understanding of DevSecOps. So I want to take a step back and kind of refresh what it is, why we wanted to look into how to adopt it into the software development lifecycle, and then also some of the practical guides, some of the tools, some of the best practices related to DevSecOps, then some of the common myths, latest trends, and Q&A session. So as I mentioned, I'm planning to have like a 40-minute presentation and then 20 minutes for us to kind of discuss in more details. Okay, so this is the journey, and I'll repeat that throughout the presentation. DevSecOps is a journey. So let's start our journey, right? So first of all, let's take a look at, take a step back and look at what is a DevSecOps. Let's go back to dark ages, right? Before the Agile, before the DevSecOps, before DevOps, the standard way, and I actually remember this time, to be honest, before anything came, the standard development cycle was developers to do the code, they hand it over to QA handed over to release, and then operation team operates. So this was the what I call the dark ages. And at that time, to be honest, we didn't know any better. So we thought this is the best thing since sliced bread, and we thought this is wonderful. And then naturally, if you have this setup, we had different goals. We had what I call frictions between different groups. For example, developers and operations people, they have different goals and they have different ways to look at things, right? And if you look at that, so if we go into look at the frictions, some of the frictions I just want to bring up here is, let's start from the top. So developers typically aim to create new and innovative software solutions that address specific business needs or solve problems. Security concerns are not usually part of the consideration when selecting how to write code or what components to use. I mean, this is standard development, at least previously. I mean, now I think more developers are getting into the security, but previously the consideration for security was not really part of development cycle at all. Developers strive to write clean, efficient, and maintainable code that meets performance and scalability requirements. Unfortunately, usual requirements do not necessarily include non-fictional requirements for security. And by that, I mean, when developers get their requirements from the business, for the most part, they almost never talk about security. They talk about features. They talk about, I want to do this. I want to click here. I want to see this. And this is what we develop. I mean, consider myself developer as well. So this is what we do, but it never says, okay, I want to protect from hacker attack X, Y, and Z, or I want people to prevent doing this. It's usually never the case. Again, the next one is the primary goal is to develop new features, like I just mentioned, functionalities according to requirements. So performance, stability, and other things are not really consideration there as well. And developers often focus on delivering software updates and new features quickly to meet the market demands. They see spending time on security topics as a slowing down. And this is kind of a standard. If you talk developers, even now, a lot of them consider that to be, kind of hindrance to them. On the IT operations team side, they prioritize stability and reliability. They hate frequent releases. They consider it to be a risk because every time you have a release, there's a risk, a chance that something can go wrong. Some code, malicious code can be introduced, or, a bug could be introduced, and they focus and they don't like frequent releases. They also focus on optimizing system performance, including network, service, and databases to ensure efficient resources utilization and responsiveness. They seek to automate repetitive tasks and streamline processes, and IT operations teams monitor system health, detect issues proactively, and troubleshoot problems. So this is what they do. So while developers and IT operations, they have different immediate goals, their ultimate objective is to collaborate effectively to deliver high-quality software that meets business requirements while ensuring stability and security. So what was the answer at that time? DevOps. This is how DevOps was created, right? Let's put together IT people, development, operations, and QA people, and this is how the DevOps started. So DevOps is a methodology designed to share responsibilities more evenly and reduce finger pointing and toxicity between development and IT operations team. And this is really, comes to where I'm sure if you guys have been in the industry for a while, operations find a bug. Obviously, whose problem is it? Developers did a bad job, right? It's constantly going, pointing fingers to development, and development team is basically not happy about that as well. But putting the two together, working together, sharing what's happening makes it more smooth process, makes things to go quicker, smoother. And that's why DevOps has been such a success in a lot of places where when people work together, they understand other people's issues or, concerns, and educating each other helps to kind of all of us work together. So DevOps enables formerly siloed roles, development, IT operations, and quality engineering to produce more reliable and efficient software. So as you can see, DevOps allows all of these teams to work together. When development team is aware of operational needs and operational team is knowledgeable about development challenges, together they can create a process which addresses frictions and allows to create a more reliable, efficient application which is stable and working at optimal performance. So if we take a step further, this is the DevOps, continuous improvement. You go from coding all the way to deploying, all the way to operations monitoring, and then using the feedback from operating and monitoring, going back into the plan and fix, enhance, and make it better. So we do have one more next step. We do have another team who is kind of also have a friction with or problem with developers, which is the security team. Right? So let's look at that a little more. So time pressure versus security assurance. So development teams often face pressure to deliver software quickly, to meet deadlines or compete in the market. However, rushing through the development process can lead to security oversight or vulnerabilities. So obviously, the security team is not happy with developers either, because we run the code, we introduce the code that may have security flaws in it, and we don't even, know about them. So feature prioritization versus security need, that's another one, obviously, contention. Development team may prioritize adding new features or functionalities over addressing security concerns. This can result in insecure code or neglecting security measures until later stages of development. Another one is openness versus security. Openness and collaboration are often valued in the development process, such as using open source libraries or platforms. However, integrating third-party components without proper vetting can introduce security vulnerabilities. And the last one on the list is testing and deployment speed versus security testing. So rapid development cycles, such as those in agile or continuous integration deployment environments, may prioritize speed over thorough security testing. So this can result in vulnerabilities being introduced into production environment. So, what is the answer to this? Similar to DevOps, let's make it a DevSecOps. So let's bring the security team with the developers, with the IT operations, with QA, and try to figure it out all together. So this is what the DevSecOps is basically a logical and natural evolution of DevOps methodology. Adopting this approach allows organizations to reduce risk of releasing code with security vulnerabilities. It is approach to culture, automation, and platform design that integrates security as a shared responsibility throughout the entire IT lifecycle. It is an application development practice that automates the integration of security and security practices at every phase of the software development lifecycle, from the initial design through iteration, testing, delivery, and deployment. So basically in the standard development cycle, security testing comes at the end. Usually after everything is done, after things are deployed, this is when security comes in and says, oh, there's a problem, roll back, fix it. We can't release it to production until it's fixed. Or even worse, it goes into production and then they find out after it's in production that there's a problem and you have to fix it. So, and the problem here is that the later you find out about the problem, the longer it's going to take to fix it. Because, one, obviously developers don't remember what they did by the time it gets discovered. Maybe that person is not even with the firm anymore, or he's working on a different project. So somebody needs to find where the problem is. It obviously takes much longer than it would if you would find this problem sooner in the life cycle. So if we look at DevSecOps, so some of the things we want to look at, why DevSecOps, right? Why do we even want to look at DevSecOps? Why is it even the topic, right? And some of the statistics that I can see is you can see the average amount of money lost by business as a result of cybercrime in 23 was 1.3 million. This is average per business, right? We talk about, there's 72.7% of all organizations fell prey to ransomware attack in 2023. So obviously, the hackers are becoming more insistent. We have companies that are being attacked. We have 2,200 attacks each day on average. So one cyber attack every 39 seconds. So obviously nobody's safe anymore. And, it kind of forces organizations to start looking at security in a different light. It becomes more and more important to stay in business. You have to look at security if you want to stay in business. So some of the benefits to organizations. So this is another, 2 slides here. So we have cybercrime going up and predicted by 2027. As you can see, it's exponentially growing, right? And then another slide here, I think it's related to development. The cost of fixing a bug and security issue as well, the later in the cycle you find it, the much more expensive it is to fix. So on average, about 30 times more expensive to fix a bug or security issue or security vulnerability when it's found in the later stages of software development lifecycle. So, just to list some of the benefits, we have identifying and addressing issues in early development lifecycle is much less expensive to fix than later in the cycle, obviously. DevSecOps promotes a culture of continuous improvement in security area. Team can learn from each other and improve iteratively over time. DevSecOps encourages siloed teams to cooperate, enhancing communication, collaboration, and by incorporating security in early stages, as you'll see, it reduces risk of introducing vulnerabilities into production. And then issues can be identified and fixed faster due to automated testing and early identification. So overall, DevSecOps not only strengthens organization's security posture, but also contributes to faster delivery of reliable and secure software, ultimately supporting business goals and objectives. But also, let's not forget about developers, because there's also something for developers there as well, right? So if we look at the developers, so we look at the size of DevSecOps market, it's also predicted to increase by 23.4% each year, right? We have global cybersecurity spending is increasing. And one, interesting, the salaries of DevSecOps developers are increasing, and currently it's about 140K on average. So what are some of the benefits for us, for developers? So more lucrative job opportunities and career growth, right? Obviously, it's important for everyone. Highly sought after, so high demand for DevSecOps professionals. We have improved collaboration between teams. We can see accelerated delivery and speed up iterations by removing security gates at the end of the process. It makes fixing vulnerabilities faster and less stressful for us, helps in delivering high quality code. provides an opportunity for developers to improve their knowledge, and also it empowers developers by equipping them with tools, knowledge, and processes needed to build secure software efficiently. This is not only enhances the security posture of application, but also contributes to a more collaborative and proactive development environment. To be honest, I think it's now a necessity for developers to be aware of security topics. So if you think about this, similar to Agile and DevOps, before, if you didn't know Agile, if you didn't know DevOps, it was fine. It was not a problem. Now, almost every developer needs to be at least aware of Agile methodology, right? If not, be a part of it. DevOps, you need to be aware of it, in order for you to even find a job. And the way that things are going, I think DevSecOps is becoming one of those topics as well, where each developer will need to be at least aware of the topic, if not be involved in it. So if we look at the developer SDLC lifecycle, let's put it this way. Again, it's the same slide we saw before, it's DevOps. But then if you look at each stage of the DevOps, we can introduce security processes to help us build a more secure code. Again, these are just examples. It's not an exhaustive list. It's just examples of what we can do. So for example, at the planning stage, we can do threat modeling and code standards. So what threat model is, we'll go into each one individual later on, but right now I'll just do like a quick overview. So SASS, which is static code analysis, right? Code reviews, vulnerability scans, dynamic application security testing. We have pen testing, logs, RASP, SIEM. We have all these processes and tests and security processes we can introduce into DevOps cycle to make it more secure and allows, to build a more secure code. So let's look at, again, now jumping more ahead and trying to see first step in implementing DevSecOps, right? Is it even good fit for you? You have to look at it because it's not for everyone. It's not every company can implement DevSecOps easily. Right? So if you have agile methodology, if your existing DevOps in place, if you currently do many releases a year, there's some level of automation that exists, your culture in the company is open and, open to change and innovative, DevSecOps is going to be a great fit. It's going to be easier to implement. I think it's going to be a great fit. It's going to be successful. However, if your company using a waterfall methodology, it's highly regulated industry, it requires many approvals, it's very bureaucratic, it has only a few releases per year, it's zero automation and a rigid culture, DevSecOps may not be a perfect fit for you and it may be difficult to implement it, right? So also, let's take a look at some of the challenges of implementing DevSecOps. So it can be overwhelming. Obviously, it's a cultural change and it can be overwhelming. Culture changes are the hardest to implement, especially in organizations with rigid cultures or highly regulated industries. Another challenge is there's a natural resistance to change for many people in organizations. And if you already have a product, for example, being delivered regularly, people will be apprehensive to any changes to established development process. Another challenge is placing too much emphasis on tool instead of culture and process. Tools are just enablers. By themselves, they will not be able to solve security issues without changes to culture and appropriate training. Another one I want to bring up is organizational barriers related to collaboration, regulatory tooling, and culture. Because, for example, some organizations may have natural barriers due to regulatory restrictions, difficulty in tool onboarding, or collaboration challenges. That also may be, again, a challenge in implementing DevSecOps. Lack of security skills for developers and business stakeholders. So it's critical to educate, but not only developers, but also business. Business also needs to understand security topics and understand how important it is for developers to spend time addressing them. So that's also another challenge to educate business, educate developers as well. And if your infrastructure is very complex or includes many legacy components, implementing DevSecOps may be a challenge. Specifically, DevSecOps is using a lot of automation. To be successfully implementing DevSecOps, you have to have a lot of automation. And if you have a legacy platforms, if you have very complex infrastructure, automation may be challenged there as well. So some, again, keys to success, I would call them, right? Most important is to understand that DevSecOps is a journey. And I used that word before, journey. It's not a one stop, you did everything and you're done. It's incremental improvement. You implement something and then you continue on the journey, continue making it better, better, and better. So it's a journey. It's not a sprint. So the sooner you embrace it, the more successful you will be. It's also critical to understand that it's a culture change, first and foremost. It's a culture. Without changing the culture, you won't be able to succeed. You need to ensure that developers, security people, and business receive appropriate training. Use any means necessary official training, lunch and learn, webinars, every little bit helps. The more you can educate people, the easier it's going to be for them to accept it and for you to implement it. It's important to understand where your organization stands in DevSecOps maturity stage. Knowing where you are will help you understand what you need to do, obviously, right? So OWASP has a very good tool to help with this assessment. Based on where your organization is, you may choose different strategies to implement DevSecOps. As your organization becomes more mature, you will be able to add additional processes to make it more DevSecOps aligned. Another one is align security practices to development workflow, not the other way around. So what does it mean? Is you don't want to break your development workflow. You don't want to break your development lifecycle. You want to enhance it with security. You don't want to be a showstopper. You don't want to be a bottleneck. You want to seamlessly, get into the development lifecycle and make it more secure, better, and not interrupt it and disrupt it. So DevSecOps should be working with existing development processes and make them better and not to be a bottleneck, just like I mentioned. Encourage collaboration between teams as early on as often as possible. So collaboration is also another key component of DevSecOps. Without collaboration, it's doomed to fail. Demonstrate success in keeping up with development velocity. That's critical, especially in the beginning. You have to show that DevSecOps is going to maintain the development velocity. It can continue to develop code with the same velocity as before, yet make it more secure. Show incremental successes and build on them. Again, each success story paves the way for making it easier to do more. And then continuous improvement. Keep improving the process based on feedback and what works and what doesn't. There's no one right answer here. There will be things that work and things that do not work. But as long as you're improving, I think you're moving forward, and it's great. So here's just a flat view of previous slides. So I'll just move on. So I want to deep dive a little bit on each phase of SDLC and try to see what can be done from the DevSecOps perspective. So planning is a threat modeling. What is a threat modeling? Is to identify potential security threats and vulnerabilities that might affect the application based on its requirements. It defines threats which are potential events which can be malicious, such as denial of service attack or failure of a component, ascertaining risks related to these events, and defining countermeasures to address these risks. So one of the models is called STRIDE. And, if you look at the first letters, this is where the name is coming from. So it consists of spoofing, which is when cyber criminals pretend to be someone or something else to gain access, steal data, or spread malware. Tampering, which is unauthorized act resulting in modification of a system, component of a system, its intended behavior or data. Repudiation is the ability of a user or system to deny having performed a particular action. Information leakage is when an application reveals sensitive information that it shouldn't have, such as developer comments, error messages, plain text credentials, and so on. Denial of service is an attack which makes resources or application unavailable. And then elevation of privileges is when attacker gets access to privileges he should not have. So this is the main, threats that are considered as part of the STRIDE threat model. And then based on these threats, you evaluate the risk, and then you come up with what do you do to address those risks. So what are the benefits of a threat modeling, right? So it provides a clear justification for security decision. Often business is not aware of the implication of skipping on security, and once presented with threat analysis, it's easier to justify time and money spent on making applications more secure. So, we all know it's all about prioritization, right? Business wants new features. They give you money to build new features. Doing a threat analysis and showing the business what threats are out there and what the risks are makes it easier for them to agree to, spend development cycles on addressing these issues. It helps prioritize threats and help with development decisions, helps address vulnerabilities quicker. So some of the tools, again, these are not the full list. I mean, this is just an example of the tools. I do have a link later on where you can actually look at, all the tools that are available, but these are some of the tools that you can use for this. You have Microsoft Threat Modeling Tool, OWASP, Threat Dragon, and Synopsys. Like I mentioned, I do have a link later on so we can see. Other things to consider: define specific security requirements that an application must meet, like authentication, authorization, data encryption. Do an architecture review, evaluate the system architecture for potential security weakness, and ensure that security controls are appropriately integrated. Implement security by design principles such as least privilege, separation of duties, and defense in depth. Like I mentioned, there are other models. Some of the models are, for example, DREAD, Attack Tree, AIC, and so on. So you can definitely take a look, find additional models online. Also, I think a good one is OWASP, top 10 security threats. So you can look at that, and that gives you the top 10 security threats that they identified, and that could be, good starting point. The next, coding. This is the next phase. Again, This is not an exhaustive list. It's one example, SAST, which is Static Application Security Testing. It examines source code to identify flaws, weaknesses, and critical vulnerabilities. It also sometimes called white box because it has access to the source code. It examines the code without executing the application. It can scan for things like SQL injection, buffer overflow, cross-site scripting, and many others that you can find. Some you can find in the top 10 OWASP that I mentioned before. So some of the SAST types are formatters, linters, type checkers. These are like some of the examples. And the formatter is a tool that quickly checks to reformat your code for stylistic consistency without changing the runtime behavior. Linters is a tool that detects not just stylistic inconsistency, but also potential logical bugs and often suggests the code fixes. You also have type checkers, which is another tool type that helps ensure your code is used in the way that it was intended by detecting and warning about any possible incorrect uses. And what are some of the analysis that SAST can provide? It could do configuration analysis, so it ensures that configurations align with security best practices. Semantic analysis, examination of a syntax, identifiers, secrets. Data flow analysis, tracks data flow through the application and can check if data is validated before. Control flow analysis, check the order of the operations, potentially can identify toxic sequence of execution. Structure analysis, these are like a language-specific code structures for inconsistencies, class design weaknesses, etc. So some of the tools, GitLab Advanced Security, SonarQube, and AppScan. These, again, just examples. There are many more that you can look at. What to consider when looking for SAST tool? One big consideration is developer-friendly UI, which is easy to use for people who are not security staff. It's important for developers to have a way to see the report and understand what it represents without being, very secure aware, for lack of a better description. A speed of a scan. We do not want to slow our development lifecycle. That's also important. The quicker the scan can be performed, the quicker development lifecycle can continue. One of the problems of SAST is a very high rate of false positives, right? That's one of the, cons of the SAST. So low false positive rate to reduce time developers spend on reviewing the incorrect results. So the less issues it shows, false issues it shows, the better. And then, simple integration to CI/CD. If the tool is integrated with CI/CD easy, that's better. Other things to look at, SCA, which is software composition analysis. So it's used to identify libraries and dependencies used by the code. With developers using more and more open source code in their development, this may be a great tool to identify potential vulnerabilities related to component use. Even if your code is secure, your application may still be vulnerable through third-party components used in your application. Another is use secure coding practices and guidelines, like, for example, OWASP Top 10 to minimize common vulnerabilities. Dependency management, ensure that all the third-party libraries and components are vetted for security. Some of the advantages of SAST. It's relatively fast. It's easy to automate and doesn't require test cases. So it's kind of easier to implement than other tools in the chain. So personally, I would suggest to start with the SAST if you're implementing DevSecOps. This is a good place to start because it's easier. It provides feedback to developers right away. It can show a quick success by, showing, how quickly you can make your code better. So I think it's a good place to start if you're, implementing DevSecOps. The next phase, building phase. Building phase, dynamic application security testing is one of the examples. And what is dynamic application security testing? It's a test running on the running application. So DAS works by simulating automated attacks on application, mimicking malicious attacker. It's sometimes called black box because it doesn't have access to the underlying source code. It requires running application, like I mentioned. So some of the tools, you can have a Qualys, Guard, Invicti, and AppScan. So these are the tools, again, not a full list, just some of them. So some of the common vulnerabilities is SQL injection, cross-site scripting, broken authentication, and some of the examples of DAS types are vulnerability scanners, fuzzers, and attack proxies. So some of the pros of the DAS, fewer false positive compared to SAST. And it's also language agnostic. SAST is the language specific because it runs in the code, it's specific to each language. DAS doesn't care what language it was used to code the application. It's a black box, so it's running on the running application. So it's one of the positives. Cons, it's slower, usually slower testing, and then does not provide any code insights because, again, it doesn't know the code. It doesn't know where it came from. So it takes longer for developers to understand where the code and where they need to fix it than a SAST. SAST can actually highlight you where exactly in the code the problem is. Here, you have to do a little bit of, legwork to do it. What to consider when you're looking for the DAS tool: scanning depth and accuracy. Since many applications are complex, it's important to choose a tool that can go thoroughly and make a thorough scan of your application. Also, speed of the scan, it's also important because, again, DAS are usually slower. So you want to choose the one that does it faster to make sure that, again, the impact to the development flow is much less. Actionable vulnerability report. Tools which provide a detailed report which can help developers identify issues quicker are preferable. So the more information it can provide about the problem, the easier it will be for developers to find where the problem actually is. And also, again, simple integration into CI/CD. So I would suggest the DAS would be the second step, right? First, start with SAST. Once SAST is done and implemented, then DAS would be the next logical step of implementing. The next phase is testing. Again, not exhaustive list, just one: pen testing. Pen testing is penetration testing. And it also could be used in other stages as well. Could be used after deployment, it could be used during the build phase, deploy phase. It could be used, after it's deployed, but it could also be done as part of the testing phase. So it's a simulated cyber attack to check vulnerabilities. It can be done by external companies. There are quite a few companies out there who specialize in doing the pen testing, but it could also be done internally, in-house. And there are certain tools that will help you do that. Some of the tools: OWASP Zap, SQL Map, OpenVAS. These are some of the tools that you use for pen testing. Also, like I mentioned, you can also do SAST and DAST scans during this phase as well. Cognizant of time, so I'm going to skip some of the things. So release, you have a compliance check. Usually this is where you do a compliance check. What is a compliance check? There may be multiple organizational policies and standards which need to be checked as part of the release cycle. So some of the things are open policy, agent, chief inspect, AWS config. So these are the type of checks that you would run during the release. Deploy, one example, SSL. This is specific to web. So SSL verification is necessary to ensure your certificate parameters are as expected. So one of the things that you can also do: configuration management, environment hardening, infrastructure as a code is also another thing that usually comes into this phase. Again, you can implement DAST, load testing, performance fuzzing test at this stage as well. And finally, we have operate and monitor. And this is where, continuous monitoring, which implement monitoring and logging to detect and respond to security incidents promptly, regularly apply security patches and update to the application as dependencies, have a plan in place to respond to security incidents promptly and effectively, educate developers and other stakeholders about security, best practices, and your findings. And also, you can also do periodic pen testing here as well. Let's move some of the best practices. So I'll go through them real quick, and then we can discuss some of them during QA. Regularly train development and operations team on secure coding practices and emerging threats. Encourage collaboration between development, security, and operational teams to foster a culture of shared responsibility. Conduct blameless postmortems after security incidents to learn from mistakes and improve processes. Conduct through peer code reviews with a focus on security. Ensure that feedback from security testing and monitoring is quickly communicated back to developers. Use tools like SAST, DAST, and SCA to automate vulnerability detection. Then the next one is embed security considerations from the earliest stages of development. This includes design review, threat modeling, and secure coding practices. Incorporate automated security tests within CI/CD pipeline. Implement continuous monitoring for security threats. Manage configurations through code to ensure consistency, enable automated security checks, use tools to manage secrets, keys, and token security, and conduct regular security audits and vulnerability assessment to identify and remediate weaknesses. Some additional thoughts: don't try to implement everything at once. DevSecOps is a journey, like I mentioned before. It's not a sprint. Keep in mind it's a cultural shift. Raise awareness as much as possible. Again, use any avenue to educate. Try to use any way to do it. Prioritize based on biggest gaps depending on resources, needs, and culture. Choose top 3 bad things and focus on them. Focus on eliminating class vulnerabilities. Implement things incrementally and find the right tools and best way to implement them. This is, as I mentioned, there is a DevSecOps tool periodic table, which actually lists, based on different needs, what tools you can use. There's also a useful links. You have OWASP that I always keep bringing up. This is a great resource. It's open source foundation for application security. It has tons of information about overall DevSecOps. Also, top 10, which is top 10 vulnerabilities. Excellent resource. NVD. This is the vulnerability database. This is the government site. It has a list of known vulnerabilities, which is a great resource. You have periodic table, which I showed before, DevSecOps manifesto, and you can look at that and, to learn about that. And also some of the Microsoft, GitHub, and CSA, some of the definitions of DevSecOps. I do have just a couple more slides, so I'll try to run through them real quick. I know I promised 20 minutes of QA. We'll get there like four more minutes, and we're going to get to that. Just give me a minute. So common myth, right? So what is common myth? I also call them excuses, right? When you try to do the DevSecOps, people bring this as an excuse not to do it. So one of them is security and compliance are single point in SDLC. So they say, okay, we do it at the end, that should be good enough. In reality, security and compliance are the most effective when they're implemented throughout the SDLC lifecycle. So that's obviously not true. So adding more tools will solve security and compliance issues. That's also not true, because adding more tools just increases complexity. Without proper training, culture changes, it will not resolve security issues in development lifecycle. Another one is DevSecOps is purely technical challenge. Again, it's a bigger cultural and human challenge than technical. Without changing the culture of organization, the best tools will not guarantee the results. One size fits all. Definitely not the case. Every company is unique. Every industry is different. So there is no one single right answer, right? Each organization will require a different approach to implement DevSecOps. Security slows down development lifecycle. And this is like a common one people use. Oh, it's going to slow us down. In reality, it's empowering developers to ensure their product gets to production with appropriate security built in. By allowing to identify security issues early in development lifecycle, it takes less time to fix than, trying to do it at the end. And then DevSecOps is purely cloud native. Again, that's also another one. It's great for the cloud, but it also, works great in other environments as well. So cloud is not the only place where you can implement it. Some of the trends, I just want to focus on the three that I think is pretty cool. So increased emphasis on security automation, right? So obviously, DevSecOps is heavily dependent on automation. So CI/CD pipelines, there's emphasis now on automating as much as possible. That's a trend currently in the industry. Another one is AI. I mean, I love AI. So the cool thing about this, there are ways that, AI is now being used as part of the DevSecOps, right? And one of them is in places where the velocity of processes and the volume of data exceeds human capacity for analysis. So machine learning, AI, security tools can provide amazing results. And also, coupling SaaS tooling with generative AI speeds up the process by suggesting AI-generated code fixes to developers, which is also pretty cool. So when you get the result of SaaS tool, the AI can actually suggest what fixes to do in your code, which is, very helpful for developers. And the last one is, threat modeling. I mentioned that before. I think threat modeling has been difficult to implement, but I think it's a great tool because it allows business to understand how critical security is. It allows to build a case to spend money on it and allocate development resources to fix it. So, I think it's also great that this is becoming more and more prevalent in the industry. So I think I came to the end. I mean, this is it. These are some of the sources, and then the Q&A. So I want to, not just ask the question, but also if you guys have something you want to share with the group as well, I think I want to encourage that as well, because like I said, it's not one answer for everything. So if you have something you want to share with the group and, maybe they can use some of that knowledge that you have as well in their journey. All right, so go ahead.
To learn more about our training programs, classes, and what sets us apart, please visit our website at www.computercoach.com.